Hello and welcome to the first bonus episode of our rigid body tutorial. In the last episode we added hinge joints and a little bit of code to avoid collisions between bodies. And in this episode I'm going to show you how we can do it the right way. Well, I don't know if it's the right way, but it's used in Box2D, I think, and in Unity, and we are using collision masks and collision groups. I'm going to show you how we can do that. Though there's a small requirement for you. You should be a little bit, at least a little bit, familiar with bitwise operations. I'm trying to explain, but I don't know if I can explain it good enough. So let's see what I can do. So then I guess let's jump to Visual Studio and let's implement our collision masks and collision groups. First, I'm already created the collision groups.js in the optimization, and I almost forgot to change the font size. So, oh no, it's already set. All right. Right. Okay. Good. Well, anyways, I created the collision groups.js file already in the optimizations folder, just because I didn't know where to put it. And I didn't want it to put it right there in the main folder, so I put it in optimizations. But it's up to you where you wanna put that. And I think that's our own. That's the only file we need to add. Don't forget to add this file to the main HTML file. And then we can go and implement our collision groups. Collision groups are, well, these are groups to group objects in, basically. So, for example, if you have objects like trees, for example, grass and bushes, all of these are groups. You know, you have a tree group, you have a group of bushes, you have a group of flowers, and so on. And this is now what we're going to do in our collision groups. We are defining some pre-made groups. And these groups, I'm going to call these collision groups, of course, like the file name. And with the right letter, collision groups, right. And now it's getting a little bit complicated because now we're doing bit shifting. That means, let me just write one example here. Group 0 will have this representation, and that means that the bitwise representation will be like this. Oh, sorry. This one. This is the bitwise operation which will be a number of 1. And we are doing this one with all the other groups too. So we have in total 8 groups. So let me add all these ones. I'm just gonna copy this one till 7. And we are bit shifting every group 1 bit more to the left. And what is now happening here is that this one here will go to the left. So this will be this one. This one will be this representation, and then there's one here, one there, there's a 1, and there's a 1. Okay, and of course these are all zeros. And this number here now changes to 2. This one is a 4, this one is a 8, 16, 32, 48, and 128. And this is now our collision groups, and we're representing our groups by bitwise. By a bitwise representation or by a bit representation. And then also there's a default collision, which everybody will have as a default. And we can say that everybody will collide with every group in its default configuration. So I'm just copying this one again. There you go. So this is group 0, group 1, group 2, group 4, group 5, group 5, group 6, group 7. And what I'm doing here now is a bitwise operation. And this default collision here will have a representation of 1, 1, 1, 1, 1, 1, 1, 1. And this is the number of 256. And yeah, what we're gonna do then is in the rigid body class, we're gonna compare the mask. Well, we are basically comparing groups against other groups. And that's actually, it's pretty simple if you know how it kind of works. But I think we get there. So to the rigid body first, we have actually we can remove this line, and we also don't need these methods here anymore, and this one too, and I actually can remove this one also. And I'm changing this method to can collide with. Okay, so a rigid body will have, we are in the constructor here right now, a rigid body will have a collision mask, which will have the default configuration, so default collision. Okay, and then it's gonna have a default collision group. This will be collision groups, and I'm gonna set that to group 0. Then we have two more two more methods. This is set collision masks. Well, set collision mask actually. This will have a parameter of mask, and we're gonna set this one to the collision mask. And then we have the same thing for set collision groups. Well, for the groups. There you go, and this will have a parameter of group, and we can set this one to group. There we go. Okay, and now we are implementing the can collide function, and this is where the magic happens. We can return this dot collision mask, and we make a bitwise and then we are comparing our collision mask with the rigid body, with the group of the rigid body, okay, with the other rigid body. And if this one is not 0, then we can collide with it. So what does it mean? If the rigid body, so let's say other rigid body has a collision group, let's say it's gonna have collision group 4, okay? The other rigid body will have a collision group 4. I'm gonna do this one. And our rigid body has the collision group we have right now 0 as a default. Let's do it like this. Then we are comparing here a bitwise AND. All right, that means that the other rigid body, the group 4, has this bitwise representation. This is this one. And our rigid body is group 0, which has this bitwise representation. Okay, and we are comparing now these two with a AND operation. So maybe I can do it a little bit better. Does this work? No, come on. Yeah, let's do it like that. Like this. Okay. And what we're gonna do now is we are comparing these two now with a bitwise AND, and a bitwise AND works like this. If there's only a 1 if both are 1, okay? If this bit is 1 and this bit is 1, then the result will be a 1. If both are 0, the result will be 0. If one of these is a 1, then the result will also be 0. So we get the result of 0, okay? Here's a 0, there's a 1, so that means we get the result of 0, 0, 0, 0, and here again 0. And this is the number of 0. Alright, so this will be 0. That means this one is 0. And yeah, 0 is not equals 0. So that means that these two objects are not colliding with each other. For example, another example, the other rigid body can also be in group 4 and group 1. So, like this. This one means if we want to set the other rigid body that it can collide, or that when we want to say the other rigid body will be in more groups than one, and we want to say like it's gonna be in group 4 and group 0, then we are doing this bitwise OR operation, which looks like this one. And here we are doing a OR operation, okay? And this means if either one of those is a 1 or both are 1, then we get a 1. So this will be 0, 0, 0, 1, 0, 0, 0, 1. Okay, and this other rigid body, so we'll have this representation. And now what we're doing here now, we are comparing again with a AND operation, and this time these 4 will be 0 because there's just 1 1. This one is 0, so that's 0. Then here again 0 0 0 till here both are 1. So we get a 1 here, and this means this one is also a 1. And this will be 1, and 1 is not equals to 0, and that means we can collide with the rigid body. It's true. And that's the logic behind collision masks and collision groups. And now we are almost done with everything. I think I'm gonna let that comment right there. I'm gonna remove this. Yeah. Now we can go to the simulation class and add some logic so we can see if it's actually working. Okay, this rectangle looks good. I don't want to change this one. I think this one is also fine. I want to change this circle. And first I'm going to create a anchor ID. So anchor circle ID is equals to circle create anchor. This will be a new vector too. Minus 60 and 0. Alright, then we are creating the circle here, and then I want to push this rigid body. And then, yeah, we are also adding another joint connection right there. But I'm also removing the other circle, I actually can remove here everything. We don't need that. And here I'm creating a new joint, okay? So let's do that. This will be a joint connection 2. I'm just gonna call it 2. Will be a new joint connection. This will be our rigid body with the anchor rect ID. Then we are creating a new connection to rect2 rigid body. Oh, we actually have that already. Oops. What I mean was I want to do that to the circle rigid body and to, one second, I'm a little bit confused. Rect rigid body, anchor, okay, anchor rect ID, there we go. And then here, circle rigid body, and then anchor circle ID. Okay. Yeah, that's right. And then we can push this joint again. And this will be also a hinge joint with that joint connection too. There we go. And also we need to call this can collide method, or actually we need to change this one because we already added it somewhere. So scroll a little bit down. Right there in our update method, I'm gonna change this one to can collide with. All right. And then we have to set our collision groups. Because if we are starting this, so save and go to browser. Oh yeah, before this one, we also need to change something else. And this is in the hinge joint. In actually, I think in every in every joint we need to change this method to something else. Yeah, and actually we just can remove this line. So just remove this line because we don't have it anymore. We also can actually remove this one, this comment, this console log. So remove the add non-colliding thing, and also I think that's it. Yeah, we need to do that in the fixed joint too. There. All right. And then, yeah, we have to also say new joint connection. And now we can go back to the browser and see what's happening. So refresh, and there we go. You can see there is no collision anymore. Well, I mean the exact opposite. There's a collision between the rectangle and then our other rectangle, which wants to be a hinge joint, but it's now pressed out of that, and we don't want that. We want that this rectangle is in this other rectangle, so there's no collision between those two. Okay, so let's do that. Let's go to Visual Studio again, and let's change the collision groups. All right. After the rigid body push, after all the pushes for the rigid bodies, I'm gonna say rect. Well, I'm gonna do every collision group now. So the rect rigid body, this is this one. This is our kinematic body. Will be in the collision group 1. So let's do that. Collision group 1. Our rectangle, our second rectangle, which is our hinge joint. Well, this rectangle is connected with this rectangle using a hinge joint, and this rectangle needs to be in a other collision group. So collision group, say collision group 3, for example. I want to put that into 3. No, actually, I'm going to set that to 2. And then we have the circle. You know, I'm going to group this. This rectangle is a kinematic, so I put all kinematics in group 1. This rectangle is non-kinematic, but it's a rectangle, so I'm going to put it in group 2. And the circle is not a rectangle and also not a kinematic, so I'm going to put this one into group 3. Yeah. That's why I'm doing these groups here, like it is. And then I'm going to set the mask. So, direct rigid body. Well, for the rigid body, the collision, we can set this one to the collision group, group 1, because it's not colliding because it's a kinematic. I mean, it won't collide, yeah, with other bodies. Yeah, all right. Sorry, it's a little bit confusing even for me sometimes. Yeah, this rigid body here won't collide with anybody, so I'm gonna set it just to group 1. Then we have the rigid body 2, which also has a collision mask, and this rigid body wants to collide with group 3. So our rectangle wants to collide with our circle. Okay, and I also need to say that for our circle, that the circle rigid body wants to collide with our rectangle. So I also need to set the circle to say that the circle wants to collide with group 2, I think it was, for the rectangle. Right. There we go. And now when we go to the browser again, and I'm gonna press restart, now our hinge joint is not colliding with the rectangle anymore, but with the circle. But not with the circle. We need to change that because yeah, I want that the circle is colliding with the rectangle. I think I made a small mistake there. So let's go back and see what I did there. All right. Yeah, what I did wrong. Obviously, I used the wrong group here in the rigid body class. This is happening when you don't have correction, some sort of a correction or a yeah, a error analyzing tool like you normally have. And this group, there you go. I almost made another mistake there. Yeah, we need to set the collision group, all right? Not this dot group, because we only have a collision group, not just a group. And now if we go back to the browser, it should work. There we go. Our rectangle is colliding with the circle, and our circle shouldn't collide with the rectangle, well, with the kinematic rectangle. All right. Cool. And also, I think you already noticed that our circle is not colliding with, I think, with the boundary. Did I saw that right? Yes. And the reason of this is that we also need to set the other group for the circle. Yeah, no, the reason, sorry, my confusion with again a little. The reason because the circle can't collide with our boundary here is because I made a small mistake. And yeah, the mistake is that I set the collision group for every rigid body to 0. So, and it's saying here that the rigid body is in group 3 but not 0, and we're also not saying that it wants to collide with group 0. There you go. We can say the rigid body wants to collide with collision groups dot group 0, and now when we go back, then the circle should collide with our boundary. Ah, damn it. Come on, circle. And come on. All right. Come on. Yeah. All right. Here you can see it's colliding. Okay, let's try again. Maybe yeah. Now okay. Now you could see it better. Yeah, we can do it like this, or I think I can also set the default collision in the rigid body to just, I mean the groups also to default collision, and then it's totally safe that everything will collide with everything in its default behavior. All right, and now we finally have collision groups and collision masks, even though they are sometimes a little bit confusing. Yeah, that's it for this episode. Um, in the next bonus episode, I'm gonna show you how we can do a collision matrix. You probably saw that in Unity already, where there's just a triangle and visualized which object can collide with other objects, and that's what we're going to do in the next bonus episode. Well, no, actually, we are implementing um, the logic behind the collision matrix, and we are displaying it then in the next episode of the next episode. Yeah, and that's what we're gonna do next time. All right. Um, yeah, that's it for this episode. Thank you for watching, and hopefully see you in the next bonus episode. Bye bye.